Okay, in this video we're going to go ahead and cover section 5.5, which is trig equations. Every time we're going to be solving an equation, I'm going to go ahead and point out what kind of equation it is, and that's going to help you identify on how to solve it. We're going to start with the first form, which is the easiest, is linear form. Remember, linear form comes in the equation of y equals mx plus b. In this case, we only have one variable, which is our x. If you notice, there's a variable here, and that's what we're going to be solving for. Okay, and what we're going to do is go ahead and solve this equation. What I want you to notice is that sign is positive in two quadrants, in quadrants 1 and in quadrant 2. So here's quadrant 1 and here's quadrant 2. So as you can see, if we graph this sign function, you're going to have multiple solutions. Okay, so we're going to be doing one of two things. We're going to be specifically identifying between an interval what solutions we're looking for, or we're going to solve for all of them. Okay, so here we have two solutions between 0 and 2 pi. So if I look between here 0 and 2 pi, we only have two solutions, quadrant 1 and quadrant 2. Okay, let's go ahead and start with the first one. Here it says solve the equation in the interval, and here's our equation. So in this problem here, what I'm going to do is I'm going to go ahead and isolate the cosecant and then leave the numbers on the other side. So I'm going to go ahead and subtract cosecant x from both sides, and these will cancel. Okay. Over here I'm going to have 2 cosecant x is equal to 4. Now I can go ahead and divide both sides by 2. Now here's one of the things that I see a lot of problems with. When do you know if you can divide and not divide? If you have a coefficient before the trig function, we can divide. If you have a coefficient before the variable, you cannot divide. So I'm going to go ahead and divide here by 2 on both sides. And that gives me a cosecant x is equal to 2. Now, cosecant, remember cosecant is the reciprocal of sine. Sine is positive in quadrant 1 and in quadrant 2. So we're going to look for the value where cosecant is equal to 2. So if I go to my unit circle, all I'm going to do is look at my sign, and I'm going to be able to flip it. So this, if I flip this one here, I get 2, which means one of my solutions is pi over 6, and the other one would be 5 pi over 6. Okay, so we're going to have x is equal to pi over 6 and 5 pi over 6. Okay, number 2 says solve the equation over the set of real numbers. Notice on this one, we don't have any restrictions. Here it's saying specifically on one unit circle. Here it does not. It just says the set of real numbers. That means we want all solutions. Whenever you want all solutions, you want to make sure to write your answer in terms of an equation. Okay. Notice that this is also in linear form, so I'm going to take the number and move it over to the other side so we can isolate the variable. Okay, so here this will cancel, and I'm left with the square root of 2 cosine x is equal to -1. Okay, now I'm going to divide. Remember, the coefficient is before the trig function, so I can divide by the square root of 2. Okay, now I'm given cosine of x is equal to, instead of rewriting this, I'm going to go ahead and write it rationalized. So it'll be negative square root of 2 over 2. Okay, remember cosine is your x value, so if I go to the unit circle, I'm looking for cosine or x to be negative. X is negative in quadrants 2 and in quadrant 3. So what does x have to be? Okay, here it does not state if it needs to be in degrees or radians, so either answer would be correct, but we're going to go ahead and use radians. So since x is negative square root of 2 over 2 here, our very first angle is going to be 3 pi over 4. Okay, so x can be equal to 3 pi over 4. Okay, now part of the problem is, remember, it's asking for the set of over real numbers, which means it needs to be an equation. This is only one solution. Okay, where would another solution be? Well, if you're thinking in terms of just this angle, which is right here, another solution would also be 2 pi later. Remember, the coterminal angles are the same as the standard angles. So what I can do to my equation is just say this value plus 2 pi n. N is going to be a real integer. Integers are negative and positive whole numbers that include 0. So if n is 0, then the first answer would just be the 3 pi over 4. If n is 1, then we're saying 3 pi over 4 plus 1 full rotation. Okay? If we say n is negative 1, then we would say 3 pi over 4 minus 1 full rotation. Those are the same thing as your coterminal angles. Okay? This is only one solution though. Remember, cosine is negative in not only quadrant 2, but also in quadrant 3. So my second answer would be 5 pi over 4. So that's going to be my second answer, 5 pi over 4. Same thing here, you have to add 2 pi n to get all solutions, okay? The way that your book or Alex will show you will be written similar to this. X given, x is equal to 3 pi over 4 plus 2n pi, comma, x equals to 5 pi over 4 plus 2 pi n. And then close your brace. All right? N is any integer. All right, next problem. Okay, number 3, what we're going to do is, here it has the instructions. We're going to go ahead and follow those, but it's similar to what I was doing before. We're going to isolate the x. In order to do that, we're going to move the 5 over to the other side. So I'm going to rewrite the equation right here. Okay, so I'm going to add 5 to both sides, and I'm left with 8 cotangent 2x is equal to 8. Now, because of the coefficient being before the cotangent, we can divide by 8 on both sides. We get cotangent 2x is equal to 1. Notice now we have a 2 after the cotangent but before the x. In this case, you cannot divide by 2. That's a very common mistake that I see a lot. What we need to do is get rid of the cotangent first. In order to get rid of the cotangent, that's when we use our inverse. So I'm going to say 2x is equal to the inverse cotangent of 1. Okay? Okay, so cotangent is going to be positive 1 at pi over 4, and it's also going to be positive 1 at 5 pi over 4. So remember, for cotangent and tangent, it's a very specific situation where the period for those two functions is where you add pi. So if I were to add pi from here, I get the exact answer for the next one here. And if I were to add a pi here, I would get the very next solution. So tangent and cotangent have a special case. I don't need both of the solutions to solve for this one. I can just use one. And I'm going to use the pi over 4. So I'm going to write 2x is equal to pi over 4 plus, instead of using 2 pi n, we're going to use pi n, where n is going to be a real integer. Okay, the next thing we're going to do is notice that the x is not completely isolated. It still has the 2 in front of it. So what I need to do now is go ahead and divide everything by 2. So I'm going to do it like this, divide by 2, and then I have x is equal to pi over 8 plus pi times n divided by 2. Okay. Now I'm going to let n equals our integers, and we're going to start at 0. So let's go ahead and just plug in a 0 here. Of course, that would make all of this 0. So the first answer would be pi over 8. If n is equal to 1, okay, so what I'm going to do is go ahead and substitute 1 for n, and I'm going to get pi over 8 plus pi over 2. If I were to add these two, I'm just going to put this in the calculator. I'm going to say 1/8 plus 1/2, and then change that back into a fraction, second PRB, and I'm going to get my second answer as 5 pi over 8. Don't forget to include that pi back in there. Okay. Notice that 5 pi over 8 is within the interval of 0 and 2 pi, so we're going to keep going. Let's say n is equal to 2. Then x will equal to pi over 8 plus 2 pi over 2. All I did was substitute the 2 here. And then I'm going to get 9 pi over 8. Okay. 9 pi over 8 is still within the interval of 0 and 2, so I'm going to keep going. N is equal to 3. We get x is equal to pi over 8 plus 3 pi over 2. Use the calculator to determine what that fraction would be. I'm going to go ahead and do that here. 1/8 plus 3 halves. Notice that that's still between 0 and 2, so I'm going to go ahead and convert this one. Second PRB, second under PRB, and I'm going to get 13 pi over 8. Okay, we're going to keep going. Let's let n equal to 4. So x is going to be equal to pi over 8 plus 4 pi over 2. Okay, now I'm going to go ahead and use the calculator again. 1/8 plus essentially 2. So I'm going to add 2. Notice now that this number is greater than 2. Okay, so we don't want a number greater than 2. So since this is equal to 2.125 and it's greater than 2, we're going to reject this solution and just keep the other solutions. Okay, so I'm going to write down all the solutions. We have pi over 8, that's solution 1. Then we have 5 pi over 8, 9 pi over 8, and 13 pi over 8. Okay, so we're going to have 4 solutions in this case. Okay, number 4, what we're going to do is notice that this is a coefficient of 1, so all I need to do is take the cosine over to the other side. You cannot multiply by 2 because the cosine is still attached. So let's go ahead and do that. I'll have x over 2 is equal to inverse cosine of the square root of 3 over 2. Okay, use your unit circle to help you evaluate that. Cosine of the positive value will be in quadrant 1 and in quadrant 4. So I'm going to start with the square root of 3 over 2. My first solution can be x over 2 is equal to pi over 6. Okay, that's one of my solutions. We have another solution in this case, which is going to be 11 pi over 6, because cosine is positive square root of 3 over 2 here. Okay, so let's go ahead and put that also. X over 2 is equal to 11 pi over 6. Okay, each of these we do need to add 2 pi. So I'm going to say plus 2 pi times n, and then plus 2 pi times n. Okay, next thing I'm going to do is I have to do something with this 2. I can't just leave it there. Remember, we're solving for x. So I'm going to multiply by 2 to both sides. Okay, this will cancel and I'm left with x is equal to, and then distribute this. So that will be pi over 3 plus 4 pi n. X will be equal to 11 pi over 3 plus 4 pi n. Okay. The next thing that we're going to do is we're also keeping it at the interval between 0 and 2 pi. So now we're going to go ahead and alternate. We're going to start with this equation and then we're going to go to this one. Let n is equal to 0 for both of these equations. If I put a 0 here, then I'm going to get an x is equal to pi over 3, which falls within the restrictions. If I put a 0 over here, I'm going to get x is equal to 11 pi over 3. Now notice 11 over 3 is actually greater than 2. So this falls outside of the restriction. This number is larger than 2. This falls outside of those restrictions. So we are going to reject this answer because it's outside of those restrictions. So reject this solution because it's greater than 2 pi. Okay, so here our only solution is going to be pi over 3. Okay. For number 5, it says to find the general solution. So we don't have any restrictions in this case. We're just going to go ahead and solve for the general equation. First thing I'm going to do is remove the secant from everything inside the parentheses. So I'm going to have to do the inverse. I'm going to have x minus pi over 4 equal to the inverse secant of 2. Remember, secant is the reciprocal of cosine, which is positive in quadrants 1 and quadrants 4. Okay, so let's go ahead and use our unit circle to help us find those two values. I'm looking for cosine of 1/2 because when I flip it, I will get 2. So our first solution is going to be pi over 3, and our second solution will be 5 pi over 3. So I'm going to go ahead and write that. So I'm going to have x minus pi over 4 is equal to pi over 3 plus 2 pi n, or x minus pi over 4 can equal to 5 pi over 3 plus 2 pi n. Okay. Now we're going to solve for x by adding the pi over 4 to both sides. So let's do that. Plus pi over 4 plus pi over 4. Okay. These cancel out, and I'm going to get x is equal to 1/3 plus 1/4 is going to be 7/12 pi plus 2 pi n. Okay, this is our first equation. Our second equation, let's go ahead and add pi over 4 to both sides. Cancels out, and I'm left with x is equal to, use your calculator to help you solve for these, 5/3 plus 1/4, second PRB, second under PRB, 23 over 12, plus 2 pi n. Okay. These will be our solutions where n can be any integer. Number 6. Number 6 is now we're looking at higher degree trig equations. This one is very similar to a quadratic equation, except you're missing that middle term. Remember, our quadratic equation looks like this: ax squared plus bx plus c. In the equation that we're given, we have a squared unit, but we don't have the single one where x is to the first power. Okay, so when it's in this particular case, we can use the square root property to help us solve for these. I'm going to isolate the x by moving the 1 over to the other side. So I'm going to have 2 cosine squared x is equal to 1. Because the coefficient is before the trig function, I can divide this by 2. So I'm left with cosine squared x is equal to 1/2. And then what I can do here is take the square root of both sides. Okay? You need to do that first before you take the inverse of cosine. So now I can do cosine x is equal to plus or minus, don't forget the plus or minus, 1 over the square root of 2. Okay? Once you rationalize this, you'll get a plus or minus square root of 2 over 2. Now, cosine is positive in quadrants 1 and 4, and cosine is negative in quadrants 2 and 3. Or I'm going to have 4 answers for this particular problem because cosine can be positive or negative. Okay, so I'm going to go ahead and start with quadrant 1, and cosine is square root of 2 over 2 at pi over 4. So our solutions will be pi over 4. The second solution will be 3 pi over 4. The next solution in quadrant 3 will be 5 pi over 4. 5 pi over 4. And then the last solution will be 7 pi over 4. Okay, so that will be your solutions. All right, number 7. Now we have something that looks like a quadratic equation. We have an ax squared, a bx plus c is equal to 0. So what you're going to do is solve this like you would any other quadratic equation. I'm going to go ahead and show you how I teach my college algebra students how to do this, or you can use the method that your professor taught you in college algebra. Okay, I'm going to do the 2 times the 3, that gets me a 6. And now I'm going to find all your factors of 6. 1 and 6, 2 and 3. When I look at the b term, I see that this is a positive value, so I'm going to leave all of these positive, and I'm going to go across and I'm going to add. This is equal to 7, this is equal to 5. What I'm looking for are the coefficients to match up. So we're going to use the 2 and the 3. Okay. Next thing I'm going to do is choose how to pair this up. I can put the 2 with the 2 or the 2 with the 3. Now it makes more sense to put the 2 and the 2 together. So this is what I'm going to do. I'm going to start with the 2 sine squared x. I'm going to break this part up, and I'm going to use a different color on this one so that way you can see what I'm doing. Plus 2 sine x plus 3 sine x, and then I'm going to have the plus 3. So what I want you to notice here is this is a simplified form, but this is exactly the same thing. All I did was strategically separate the 5 sine x into a 2 sine x plus a 3 sine x. So the part in red still matches the middle term. Okay. Is go ahead and factor by groups. So I'm going to take the first 2 terms together, and I'm going to say, what do I have in common here? Okay, 2 is in common, and so is a sine x. So inside my parentheses, I'm going to have a sine x plus 1. I'm going to bring the plus down, and then I'm going to say there's a 3 in common here, so I'm going to leave it at 3, and I'm going to have a sine x plus 1. The most important thing here is you want to make sure that everything in your parentheses actually match. If they don't match, you made a mistake, so you want to go back a step and maybe try flipping these 2 numbers the other way. Okay, once these 2 match, what you're going to do is take whatever you have outside of the parentheses and we're going to combine it into a parentheses. So I can have 2 sine x plus 3 times sine x plus 1, and all of that is equal to the 0. Okay, now it looks a factored form, so I can use the property of 0 and set each parentheses equals to 0, because if 1 is equal to 0, 0 times anything is also equal to 0. So I'm going to do 2 sine x plus 3 equal to 0, and I will also do sine x plus 1 is equal to 0. Okay. Let's go ahead and solve for this one. Now this looks like a linear equation. We can solve it like how we were doing the other problem, subtract by 3. So I'm going to get 2 sine x is equal to negative 3, and then divide by 2. Okay, so sine x is equal to negative 3/2. If you remember your range for sine, it has to be between -1 and +1, and this is definitely going to be out of that range, so this answer is not going to exist. But if you don't see that automatically, all you're going to have to do is use your calculator. If I do second sine negative 3/2 in my calculator, you'll see you have your domain error. So this one does not exist. Okay. On the other side, you can see that I have a sine x is equal to a -1. This is on the unit circle. So I'm just going to look at my y and say, oh, the answer here is going to be x has to be equal to 3 pi over 2. So x will equal to 3 pi over 2. And that's going to be your solution. Okay, so for number 8, what you can see is now we're mixing our trig functions. We have a cosine here and a tangent squared here. But I want you to look at the individual terms. What do we have in common? Hopefully you can see that cosine is in both of the terms, so that means we can factor out a cosine x, leaving inside a tangent squared x minus 3 is equal to 0. Okay, now this looks very similar to our factored form, where I can set each of these parentheses equal to 0. So cosine of x is equal to 0, and then tangent squared x minus 3 is equal to 0. Cosine x equal to 0, use your unit circle. We have two locations. We have pi over 2, and we also have 3 pi over 2. So x can equal pi over 2 or 3 pi over 2 for this one. For this one, we're going to go ahead and move the 3 over to the other side, and I'll have tangent squared x is equal to positive 3. Take the square root of both sides, and then you get tangent x is equal to plus or minus the square root of 3. Same thing here. Tangent could be either positive or negative, which means we're going to have 4 solutions on this one, because tangent is positive in quadrants 1 and 3, and tangent's negative in quadrants 2 and 4. So use your unit circle to help you solve for those. I'm going to go ahead and say x here is equal to, and remember your tangent is going to be your y over x, so the square root of 3 over 1, or in other words, pi over 3. So pi over 3 is our first, and then we're going to have 2 pi over 3. Okay, over here you have a negative square root of 3 divided by a -1, which is positive square root of 3. So we're going to have 4 pi over 3. Negative square root of 3 over 1 at 5 pi over 3. Okay, so we have 4 solutions on this side, and we have 2 here. The only thing you have to do is make sure that they don't repeat. None of these do, so I'm just going to go ahead and combine them all together. And there's your solution. Number 9, if you see this, it's going to be worked out similar to number 7, but if we look at number 7, you can see that there's some major differences. First of all, you have a cosine here with the sine squared. So these aren't exactly the same. Don't try and factor it like I did here. What we need to do is we need to convert to make sure that we have all in terms of sine or all in terms of cosine. So the first thing that I'm going to do is convert our sine to cosine. So I'm going to do it like this. I'm going to say 2 parentheses. What is sine squared equal to? Well, if you remember your Pythagorean's identities, you can say sine squared is equal to 1 minus cosine squared x. Okay? Then I'm going to bring everything else down. Minus 5 cosine x plus 5 is equal to 0. Now what I'm going to do is go ahead and distribute that 2 and then combine like terms to simplify this. Okay? So I'm going to have 2 minus 2 cosine squared x minus 5 cosine x plus 5 is equal to 0. The 2 and the 5, we can add those together. So I have a negative 2 cosine squared x minus 5 cosine x plus 7 is equal to 0. Now, just because I don't like working with negative values, I'm going to go ahead and factor out a negative to make this easier for myself. I'm going to have 2 cosine squared x plus 5 cosine x minus 7 is equal to 0. So if I distribute that negative back in, you could see that I still have the same signs that I have in the previous statement. Now if I divide by a -1, then these will cancel. So I'm left with 2 cosine squared x plus 5 cosine x minus 7 is equal to 0. Now it looks exactly like it does on number 7, but we're using different trig functions. So let's go ahead and factor by groups. 2 times -7 is -14. So now I'm going to go ahead and find all the factors of -14. 1 and 14, 2 and 7. That's all we have. Because it's negative, we can see that one has to be positive and the other has to be negative. The larger value will be positive. So that means the smaller value will be negative. Okay? If I add across, I get a positive 13 and then a positive 5. This is the value that I want, so these are the two that I'll be using. Okay? Now this is where we break them up and decide which one we want to use with the 2 and which one with the 7. So hopefully you can see that you want to put the 2's together and then we'll keep the 7's together. So I'm going to go ahead and rewrite 2 cosine squared x minus 2 cosine x plus 7 cosine x and then the minus 7. Notice that the part in red, if I were to add those two together, you would still get the 5 cosine x. So we're not changing the integrity, we just strategically separated the 5 cosine. Okay? Factor by groups, you're going to take the first two together, and then we take the second two together. What's in common? 2 and a cosine. And inside, we're going to have a cosine x minus 1 plus 7, common, 7, inside the parentheses, cosine x minus 1 is equal to 0. Remember, the important thing you need to make sure is that those two match. So I'm going to take this 2 that are outside of the parentheses and we're going to group those together. This will be 2 cosine x plus 7 times cosine x minus 1 and equal to 0. So now we can set each of these parentheses equal to 0. So 2 cosine x plus 7 equals to 0. I get 2 cosine x is equal to -7, and then divide that by 2. You can see that this is going to be a ratio larger to 1, so this one is not going to exist. Does not exist. Okay. On the other side, we can have cosine of x is equal to 1. Using our unit circle, cosine is equal to 1 at 0. Okay. So x can be equal to 0. If I look at my restrictions, it needs to be between 0 and 2 pi, but not including 2 pi. So our only solution will be 0. Okay, for number 10, so first thing I'm going to do here is break up sine. This is going to be the same thing as sine x plus x, okay, is equal to cosine of x. I'm going to use my sum and difference formula to go ahead and help me evaluate this. Okay, sine positive, sine positive. So I'm going to use this one. Okay, this will be sine of x, cosine of x, plus cosine of x, sine of x. This is the same thing as u, this is the same thing as v. Just because they're identical, you can still do this. Notice that now these two are exactly the same terms, and I have 1 plus 1, so I'm going to have 2 sine x, cosine x. And then what I'm going to do here is take this cosine and bring it over to the other side. So I'm going to say minus cosine x is equal to 0. Okay, that's what I'm going to do for that part. And then hopefully now you can see you can factor out a cosine. So I'm going to factor out the cosine x, and I'm going to be left with 2 sine x minus 1 is equal to 0. Now that you have it set equal to 0, this can be equal to 0 or this can be equal to 0. So I'm going to do cosine of x equals to 0, or 2 sine of x minus 1 is equal to 0. Okay, so use your unit circle. Where is cosine equal to 0? It'll be pi over 2 and 3 pi over 2. So here x can be pi over 2 or 3 pi over 2. Okay. On this side, I'm going to go ahead and add 1 to both sides. So I get 2 sine of x is equal to 1, and then divide by 2. So sine of x is equal to 1/2. Sine is positive in quadrants 1 and 2. So I'm going to go ahead and say x is equal to pi over 6 and 5 pi over 6 together. And that will be your answer. Okay. Okay, next is number 11. What I'm going to do first is I'm going to set the cosine over to the other side. So I'm going to set it equal to 0. If you notice on this one, it's not set up correctly because we can't convert these. We can't make it to be the same. We really can't use Pythagoras identities for this. So the only way that we can change this is if we square both sides. Now, anytime we square both sides, what happens is we change the integrity of the equation. So we're always going to have to double check our answers, okay? The square here means the sine minus cosine times sine minus cosine. So I'm just going to go ahead and FOIL this, and I'm going to get sine squared minus 2 sine x cosine x plus cosine squared is equal to 0, okay? Now, notice if we combine our sine squared x plus our cosine squared x, sine squared x plus cosine squared x, that is equal to 1. So I'm going to have 1 minus 2 sine x cosine x. Okay, so now we still have that problem where we have two trig functions and they're not canceled out and we can't make it into like a tangent or anything like that. So I'm going to refer us back to the problem that we just did. Notice that this cosine, remember, if you remember, this cosine came from the other side of the equation, which was this one. So if I take it back, I can say 2 sine x cosine x, which is essentially the same thing I have here, is the same thing as sine 2x, because I just work backwards. So what I'm going to do is bring down the 1 and the minus, and this 2 sine cosine, remember this negative cosine really was on the other side of the equation, is the same thing as sine 2x. What this does, it eliminates that extra trig function, and now we have it only in terms of sine. Okay, now I'm going to take the sine over to the other side, and I'll have 1 equals sine 2x. And then I'm going to just switch these because I like having my trig functions on the other side. Okay, and then I'm going to go ahead and take the inverse. So it'll be 2x is equal to inverse sine of 1. Okay, we can evaluate this side, and I'm going to go ahead and put the 2x up here, and I'm going to say 2x is equal to, what is the inverse of sine? We'll go back to your reference sheet. So our reference sheet says, where is sine positive 1? Sine is going to be positive 1 at pi over 2. So I can say 2x is equal to pi over 2. Okay. Next thing I'm going to do is remember sine, to get to that next solution, we need to add 2 pi times n. Okay. We now need to get rid of this 2, so we're going to divide everything by 2. I'm going to divide everything by 2, and I'm going to get x is equal to pi over 4 plus, the 2's cancel out, so I'm leaving a pi times n. Okay. Now let's go ahead and let n equal 0. If n equals 0, then we get x is equal to pi over 4. Okay. If n is equal to 1, we get x is equal to, and this will be the same thing as 1 pi, or 4 over 4, so 4 plus 1 is 5 pi over 4. Right? This is still within the restrictions, so we're going to go one more time, and we'll say what happens if n equals 2. Well, when n equals 2, this becomes now 2 pi, and this will be 2 pi plus 1/4 pi, so x will be 2.25 pi, and since that's greater than 2 pi, we're going to reject this answer. Okay, so our two solutions are going to be pi over 4 and 5 pi over 4. You should definitely check these solutions to make sure that they work, because we changed the integrity of the equation. So I'm going to go ahead and do that by substituting that into the calculator. Okay, so let's go ahead and do that. I'm going to start with the original equation, and we're going to go for pi over 4. So in my calculator, make sure you're in radian mode, which I am, and I'm going to just do sine pi over 4. That's going to equal to this number, and then I'm going to do cosine pi over 4. Cosine pi over 4. Exact same answer. This should make sense, because if we go to our reference sheet, pi over 4 is right here. And you can see that the sine, which is your y value, and the cosine, which is your x value, these two exactly match. There's same sign and everything. So this one is definitely going to work. We can do the same thing for 5 pi over 4. Okay? If we go over here and we look for 5 pi over 4, we see it right here, and our sine matches our cosine. So these two are going to be correct answers. All right? So those are going to be our correct answers. Now, if you notice, this was kind of a difficult problem. We have to use identities and go back to our sum and difference formulas, which, you know, can be a little bit difficult. But remember, there's always an alternate way to do this. So let's go ahead and solve it a different way. This tends to be a little bit easier, and we're going to go ahead and do it like that. First thing I'm going to do is take my cosine, and I'm going to divide by cosine to both sides. Okay? You can still do this, because we're not changing anything, we're just rearranging it. Now, what is sine x over cosine x? Hopefully you said tangent x, and that has to equal to 1. We do have a restriction here that you need to keep in mind. And anytime you have a fraction like this, we can't just say, okay, tangent, and then now we use, there's no, restrictions, but when in fact, over here, we can say that cosine cannot be 0 because it's in the denominator. So on this one, I'm just going to make that note. I'm going to say, note, cosine x equals 0 is incorrect. Okay? You cannot use that because it will be a 0 in the denominator. All right, so cosine x cannot be equal to 0. Now let's go back here. If I'm solving for x, I can take the inverse tangent of 1. Now where is tangent positive at that ratio? Hopefully you said 1 and 3. So tangent is positive at pi over 4. And tangent is positive 1 at 5 pi over 4. Okay? Two different ways, we got the same answer. Okay, so if you're doing your problems and you're doing it a slightly different way, as long as your math is correct, you're going to come out to the correct answer. All right, next one. Okay, for number 12, we can't really do anything. We can't put the cosine over here because then we're going to have 3 terms, a trinomial, which will make things a little bit more complicated. So all I'm going to do is keep it like this, a trig function on each side, and I'm going to square both sides. Okay, I'm going to go ahead and FOIL this, and I'm going to get sine squared x minus 2 sine x plus 1 is equal to cosine squared x. Now I'm going to go ahead and try and change this cosine squared x into terms of sine squared x. Because these two are already in sine, I might as well change this one. And we're going to use Pythagoras identities. So we're going to use sine squared x minus 2 sine x plus 1 equals 1 minus sine squared x. Okay, so all I'm doing is using Pythagoras identity. These are the ones you need to know. Now I'm going to go ahead and make it equal to 0. All I did here was subtract the 1 and add the sine squared. So now I'm going to have an equation that is 2 sine squared x minus 2 sine x. These will cancel, and these will cancel, and it's equal to 0. Okay? When we get to this part, now you can say, what do I have in common? You can say, oh, I have a 2 sine in common, so we're going to do 2 sine, and we're going to multiply that by a sine x minus 1 is equal to 0. Now I can set both of these equal to 0. I'm going to do that over here. 2 sine x equals to 0, and then sine x minus 1 is equal to 0. Okay? Divide by 2, you get sine of x is equal to 0, and over here you just get sine of x is equal to 1. So where is sine equal to 0? Hopefully you said at 0 and at pi. So over here we're going to say x is equal to 0 and pi. Where is sine positive 1? Sine is positive 1 only at pi over 2, so x is equal to pi over 2. Remember, because we changed the integrity of these equations, we need to go ahead and check our work. So I'm going to go ahead and start by checking these variables. Let's start x is equal to 0. Use the original equation, and I'm going to use sine of x minus 1 and cosine of x. We're checking if these are correct. So all I'm substituting here is a 0 into our x values. I'm going to use the calculator, and I'm going to start with sine of 0, close the parentheses, minus 1. That equals negative 1. Equals cosine of 0 is positive 1. Here, this value does not work. Okay? If x is equal to pi, let's see how that changes. I'm going to start and just change it over to a pi. And I see that this comes out to a negative 1. And it equals cosine of pi, which is equivalent to negative 1. So this does work. Okay, let's try the last one, pi over 2. Okay, sine pi divided by 2 minus 1 equals 0. And cosine of pi divided by 2. That equals 0. So our solutions are only going to include pi over 2 and pi. Okay? Last problem. Alright, so now we're given an interval, and this is going to be our equation. We do have matching trig functions, so this is going to be factoring by groups. I'm going to go ahead and do this one again for you. We did an a times a c, so a 4 times a 3, which is 12. I'm going to go ahead and solve all my factors of 12, which is 1 and 12, 2 and 6, and 3 and 4. Okay? Because this is a positive value, that means these two values are going to be the same, which is a negative. Okay? Now I'm going to go across and add these two together. This will be a negative 13, negative 8, and negative 7. Since I'm looking for the b to be negative 7, I'm going to use these two values. Okay? Let's go ahead and plug it in, and hopefully you can see you're going to use the 4 with the 4 and the 3 with the 3. So I'm going to do this like I did last time, and I'm just going to add those. We're going to start with the 4 cosine squared x, and then I'm going to break up. I'm going to match it with the 4 here, so minus 4 cosine x minus 3 cosine x plus 3 is equal to 0. So these two, if I were to combine, you get the same thing as your 7x here. Now what I'm going to do is go ahead and group them. I'm grouping the first two terms together, and I'm grouping the last two terms together. This is why it's called factoring by groups. What's in common? 4 cosine. Inside, cosine x minus 1. In common, 3, and I'm going to go ahead and factor out this negative 3 because I want this to be positive. So minus 3, and inside cosine x minus 1. This is a minus because this is a negative times negative will get me a positive. Okay, and I also want to make sure that these two inside the parentheses match, which they do. Okay, so let's go ahead and combine our first two together that are outside of the parentheses. That's going to be 4 cosine x minus 3, and then the second set is going to be cosine x minus 1, and set those equal to 0. Now this looks like factor form where we set each of these parentheses equals to 0. So I'm going to go ahead and do that here. Okay, and then we solve. So 4 cosine x is equal to 3 divided by 4. So cosine x is equal to 3/4. Here, cosine x would just be equal to 1. Notice on this one we don't have this fraction on the unit circle, so we're just going to be using our calculators. Okay, first answer. We're going to do the inverse of cosine. Now remember, where is cosine positive? Hopefully you said quadrant 1 and also quadrant 4. So the value we get here for x is going to be in quadrant 1 because remember your calculator is restricting the answers just to this quadrant. So I'm going to put in the calculator x is equal to the inverse cosine of 3/4. That's going to get us an approximation. Let's do that first. Second, cosine, and we're doing 3/4, and we get approximately 0.723. Okay. Next thing I'm going to do is I'm going to find, because that's this value right here, I'm going to find what is the value from here all the way to this one. Okay, that's the value I'm looking. Remember this right here is a reference angle, and that's the angle that we have here. So this is also 0.723. So our x2 will be 2 pi minus the reference angle, which is 0.723. So I can get the second angle between 0 and 2 pi here. Okay, so I'm going to do 2 pi minus 0.723, and I'm going to get approximately 5.56. Over here, this is on the unit circle, so all we're going to do is find cosine is equal to 1, which is at 0. So x can equal 0. So our three solutions would be 0, 0.723, and 5.56. Okay. If it wanted exact answers, we could use this, and we could also use this minus what we have here. All right, that concludes this video. Let me know if you have any questions.